Swayam Prabha. Digital India. Educated India.
Now let us go to functions of random variable, and let us start with problem. Find the distribution function of a random variable y equal to g of x in terms of the distribution function of x if it is given that g of x equal to x minus c for x greater than c, 0 for modulus of x less than or equal to c, because modulus of x lies between c is actually touches 0, therefore it is 0, therefore x plus c, this is mod x, y equal to mod x. And then similar way we have to take this, and then if x is less than minus c, then x plus c corresponding g of x. Now let us go with the solution to the problem. F of y over y equal to p of x less than or equal to y, which is p of x plus c less than or equal to y, and the range varies from minus x plus c to x minus c, so that the probability of x is less than or equal to y minus c, that is f of y minus c over x, this is a structure, and f of y over y is nothing but x minus c less than or equal to y is f of y plus c over x. So, if y is positive. Next, based on this, let us go with the example. Another example, a random variable y is defined as y equal to half into x plus mod x, where x is another random variable. Determine the density and distribution function of y in terms of those of x. So, when x is positive and y equal to x, when x is negative, y equal to 0. So, that is the meaning of the corresponding picture. So, if y is negative, then fy of y is probability of capital Y less than or equal to y, which is equal to 0. Therefore, fy of y equal to probability of y less than or equal to x, which is equal to probability of x less than or equal to y, such that x is positive. So, the meaning is probability of 0 less than x less than y divided by probability of x greater than 0 means it is a conditional probability corresponding to the variable. So, it means the function is fx of y minus fx of 0 divided by 1 minus fx of 0. So, when y is negative, fy of y is 0, and y is positive, fy of y is f of x of y divided by 1 minus fx of 0. So, this function you have to remember when y is negative and y is positive. So, when y is totally negative, it becomes 0. When y is positive, corresponding function design. Y negative, fy of y is equal to 0, and y is positive, fy of y is defined like this. Next example, find the density function y equal to ax plus b in terms of the density function of x. So, let x be a continuous random variable with a probability density function. So, f of x equal to x by 12 in 1 less than x less than 5, 0 otherwise. Find the PDF y equal to 2x minus 3. The solution is, if a is positive, then fy of y is probability of y less than or equal to y is ax plus b less than or equal to y. Then probability of this can be written as what ax plus b is less than or equal to y, therefore ax equal less than or equal to y minus b, and x is less than or equal to y minus b by a. So, this is the things they written. So, the representation of the function is fx of y minus b by a. If a is negative, then fy of y is probability of y less than or equal to y is p of P of Ax plus B less than or equal to y. So, from the first step we have to write the second step of P of Ax less than or equal to y minus b same way, and A bring denominator, so that probability of x is greater than or equal to y minus b by A, since A is negative. So, the function is 1 minus of f of fx of y minus b by A if A is negative. So, from 1, Fi of y is equal to 1 by A into fx of y minus b by A. From 2, f of y over y equal to minus 1 by A fx of y minus b by A. So, combining 2 and 3, 3 and 4, one is 1 by A, another one is minus 1 by A, where therefore we have 1 by modulus of A into fx of y minus b by A. Now, you take the value y equal to 2x minus 3 and y equal to 2x minus 3. So, x becomes 1 by 2 into y plus 3. So, x is a single valued function of y. Therefore, Fi of y equal to fx of x of dx dy, and differentiate with respect to y of the above, it becomes 1 by 2. Therefore, x by 2 is fx of x already found out, and substitute it. You have 1 by 24 of x, where x equal to 1 by 2 into y by 3, substitute. Therefore, 24 into 2 is 48 into y plus 3 in the interval minus 1 less than y less than 7. So, the range of y is obtained from the from that of x using the relation between the x and y. Next example, if x is a continuous random variable with some distribution defined over 0, 1 such that probability of x is less than or equal to 0.29 equal to 0.75 given, and determine k. Therefore, probability of y less than or equal to k is 0.25, where y equal to 1 minus x. So, the solution is probability of y less than or equal to k is 0.25, and therefore, this can be written as capital Y is what 1 minus x, because x plus y equal to 1. Therefore, y equal to 1 minus x less than or equal to k equal to 0.25. From this, x is greater than or equal to 1 minus k equal to 0.25. Therefore, probability of x less than or equal to 1 minus k is 0.75. So, probability of x less than or equal to 0.29 is equal to 0.75. So, comparing 1 and 2, we have k equal to 0.71. So, based on that, we have an example. If y equal to x square, where x is a Gaussian random variable with 0 mean and variance sigma square, find the probability density function of a random variable y. So, the solution is f of y over y equal to p of y less than or equal to y, which is equal to probability of given y is x square, therefore, x square less than or equal to y. The mean is probability of this x square root, take it, therefore, x capital X less than or equal to root y. Therefore, this can be written as minus root y less than or equal to x less than or equal to root y. So, this is what they written here, and if y is positive, then f of root y over x and f of root of minus y over x. If f of y over y equal to 0, mean if y is less than 0, since x square equal to y has a no root. Now, differentiate f y of y equal to 0, and if y is negative, therefore, x square equal to y has a no root. when y is less than 0 and differentiate 1, right. Differentiate 1, what happened? With respect to y. Therefore, so this is equation 1 and fy of y will come, it becomes 1 by 2 into root y into fx of root y plus fx of minus root y, otherwise it becomes 0. So, x follows n of 0 comma sigma. So, fx of x is 1 by sigma into root pi into e power minus x square by 2 sigma square when x lies between minus infinity plus infinity. Using this value in 2, we get f of y over y equal to 1 by sigma into root of 2 pi into y equal to e power minus y by 2 sigma square. So, this is the corresponding value. Now, let us go with another problem. If the continuous random variable x has the PDF and f of x over x equal to 2 by 9 of x plus 1, where x lies between minus 1 to 2, find the probability density function y equal to x square. So, the transformation function y equal to x square is not a monotonic. So, we divide the interval into 2 parts, that is minus 1 comma 1 and 1 comma 2. Since minus 1 comma 1 is a symmetrical interval, therefore, f of y over y is found out by using the formula of the previous one, and x lies between minus 1 to 1, y lies between 0 to 1. So, the previous formula of fy of y is given here. Equation 2 is fy of y and substitute here. So, y is x square is given, therefore, x equal to root y. So, x equal to root y is varies from negative and positive limit is 1 plus root y and 1 minus root y, and then substitute it and simplify. So, root y get cancelled, 2 by 9 plus 2 by 9 is a 4 by 9. So, 2 get cancelled, so 2 by 9 root y will come. If x lies between 1 to 2 and y lies between 1 to 4, then y equal to x square is strictly increasing. It means x you know and fx of x is you know, fy of y is also know. Therefore, fx of x related to this function is given, is here given. This is the reference, you have to take it, and then differentiate with respect to y of this, it becomes 2x here, substitute, and after simplification, so 2 get cancelled. So, 1 by 9 into x plus 1 by x and x equal to root y, therefore, substitute, therefore, 1 plus root y will come, f of y over y. So, this is a way we can find the transformation of the PDF in terms of the function y equal to x square. So, according to the Maxwell-Boltzmann law of theoretical physics, the probability density function of V, the velocity of the gas molecule, is given by f of V over V is equal to kV square into E minus A into V square, where V is positive, 0 otherwise, where A is a constant depending on its mass and absolute temperature, and K is an appropriate constant. Show that the kinetic energy y equal to half into mv square is a random variable having gamma distribution. By property of PDF, the function is Fv of v is equal to 1. So, Fv of v is integral 0 to infinity v square e power minus a into v square dv equal to 1, and this becomes k by 2a into root a integral 0 to infinity t power 3 by 2 minus 1 into e power minus t dt by putting t equal to av square. Therefore, k by 2a into root a is what? T power 3 by 2 minus 1 is into e power minus t is a gamma function. So, this is the gamma of root of 3 by 2 equal to of. So, gamma n plus 1 equal to n gamma n. So, here gamma of 3 by 2 equal to gamma of plus 1, which is equal to of gamma of. So, that is what written here, gamma 3 by 2 is of into gamma of. So, k by 2a into root a equal to 1, from this k equal to 4a into root a by pi, root pi, where gamma of value is root pi. So, that is the value of k. So, you have to remember gamma function. So, gamma n is equal to integral 0 to infinity e power minus st into f of t dt, or e power, that is minus t till 0 to infinity e power minus t into what? T power n minus 1 into dt. So, corresponding we have a gamma function. So, these things you have to recollect and do the process. Therefore, from the previous step y equal to m by 2 into v square, from this set v square v equal to plus or minus root of 2i by m. Since v is positive and v equal to root of 2i by m is a only admissible value, from this we can calculate fi of y is fv of v into dv by dy, and fv of v already we done it. V you know differentiate with respect to y and simplify and convert in terms of the y, we have the value. So, this is called as gamma distribution or Erlang distribution of two parameter. Next problem, given a random variable x with the density function f of x equal to 2x, where x lies between 0 to 1, 0 otherwise, find the PDF of y equal to 8x cube. Here y equal to 8x cube is strictly increasing function. So, fi of y equal to fx of x into modulus of dx dy. Here x equal to 1 by 2 into y power 1 by 3, differentiate we have 1 by 3 into y power 1 by 3 minus 1 by 2. Therefore, fi of x is equal to y power 1 by 3, and this result is 1 by 6 into y power minus 2 by 3, and substitute we have 1 by 6 into y power minus 1 by 3, where y lies between 0 to 8. Another example, if x is a Gaussian random variable with a mean 0 and variance sigma square, find the PDF of y equal to modulus of x. So, we have fi of y equal to probability of y less than or equal to y, which is equal to probability of mod x less than or equal to y. So, we have a p of minus y less than or equal to x less than or equal to y, means f of y over x minus f of minus y over x. So, the solution is differentiating both sides with respect to y. So, we have this becomes fi of y, fx of x, already we have inside minus minus and minus plus, we have fx of minus y. So, it follows n of 0 comma sigma. Therefore, fx of x is 1 by sigma into root pi into e power minus x square by 2 sigma square, where x lies between minus infinity plus infinity. So, using 2 in 1, we have fi of y equal to 2 by sigma into root pi into e power minus y square by 2 sigma square. Next example, if x is a normal random variable with a mean 0 and variance sigma square, find the probability density function of y equal to e power x. Number 2, if x has an exponential distribution with the parameter alpha, find the PDF of y equal to log x. So, number 1, fy of y is fx of x into modulus of dx by dy, where here y equal to e power x, and y differentiate with respect to y mean very difficult, therefore, taking anti-log x equal to log y. Now, we differentiate with respect to y, it become 1 by y, therefore, 1 by y into fx of log y we can write. So, already you know fx of log y is what? 1 by sigma y into root pi into e power minus of log y minus mu the whole square by 2 sigma square. So, this is called as PDF of log normal distribution, and fy of y equal to fx of x into modulus of dx by dy is e per y into alpha into e per minus alpha e per y, where y lies between minus infinity to plus infinity. Next problem, if x is a normal random variable with the mean 0 and variance sigma square, find the PDF y equal to e power x. So, if x has an exponential distribution with the parameter alpha, find PDF of y equal to log x. Now, the formula is fy of y equal to fx of x into modulus of dx by dy, and y equal to e power x is a monotonic, you know, and substitute it, you can get it. So, the PDF of log normal distribution will be generated. Next problem, if x has an exponential distribution with the parameter 1, find the PDF of y equal to root x, and x has a Cauchy's distribution with the parameter alpha. Prove that y equal to 1 by x has also the Cauchy distribution with the parameter 1 by alpha. So, the solution is f of y over y equal to f of x over x into modulus of dx by dy, where y equal to root x. Now, differentiate y equal to root x, that is x equal to y square, and differentiate with respect to y equal to 2y will come, that is what they written, and fx of x is e per minus y square, where y is positive. So, we can easily calculate fy of y. So, fy of y is nothing but fx of x into dx dy, here y equal to 1 by x, right, that is md, and then substitute with what Cauchy distribution is alpha by pi by sigma square x square plus sigma square alpha square, and replace x equal to 1 by x, so that we will get alpha by x by 1 by y the whole square plus sigma square, and further simplify, you take the LCM of the denominator 1 plus y square alpha square into 1 by y square get cancelled, and we have 1 by pi alpha by y square plus 1 by alpha square. So, which is a Cauchy distribution with the parameter 1 by alpha. Now, let us go once again the problem of 12. If the RV random variable x is uniformly distributed in the interval minus pi to pi, find the probability density function y equal to a into sine of x plus alpha, where a is positive and alpha are constant. The horizontal range of the projectile is given by r equal to v square by g into sine 2 theta. If theta is uniformly distributed in the interval 0 comma pi by 2 and v square by g is a constant, find the PDF of r. The solution is, if mod y is greater than a, no solution exists, therefore, fy of y equal to 0. If mod y is less than a, there exists two values of x in minus pi comma pi. Therefore, xr equal to sine inverse of y by a minus alpha, where r equal to 1 2, and differentiate with respect to y. Therefore, the above differentiate sine inverse differentiate 1 by root of 1 minus y by a the whole square into with respect to y is 1. So, y equal to x equal to sine inverse x, sine inverse y with respect to y is 1 by root of 1 minus y square. So, this technique apply here. So, here a is there, therefore, 1 by root of a square minus y square will come. Therefore, Fy of y equal to Fx of x1 into determinant modulus of dx1 by dy plus Fx of x2 into modulus of dx2 by dy. So, this value is 1 by root of a square minus y square, and this one is equal to 1 by root of a square minus y square because of x equal to 1 by 2 pi. Now, add them, 1 by 2 is 1, therefore, 1 by 2 get cancelled, that is twice of this, 1 by 2 pi, 1 by pi into root of a square minus y square will come. This is true if mod y is less than a. If theta is uniform in the interval 0 comma 2 pi by 2, then x equal to 2 theta is a uniform in the interval 0 comma pi with the probability density function is 1 by pi. When r equal to v square by g of sin x equal to a sin x, since r and a are positive, if r is less than a, there exists only two values of x in the 0 comma pi given by xi equal to sin inverse of r by a, where I equal to 1 comma 2. So, differentiate this x1 by dr and x2 by dr, so that we have 1 by root of a square minus r square, and substitute both fx of x1 and fx of x2, so that we have 2 by pi into root of a square minus r square. If r is equal to a, then it becomes 0. If r lies between 0 to a, this corresponding values. Next question, if x is uniformly distributed in the interval minus pi by 2 to pi by 2, find the probability density function of y equal to tan x. Number 2, if x has a Cauchy's distribution with the parameter 1, find the probability density function y equal to tan inverse x. So, if x is u of minus pi by 2 to pi by 2, then fx of x equal to 1 by pi, therefore, y equal to tan x. Therefore, x equal to tan inverse of y, which is a single valued function, and there exists one value tan inverse y in the minus pi by 2 to pi by 2. Therefore, Fy of y equal to f of x over x into modulus of dx by dy. So, which is equal to 1 by pi by 1 plus y square, where y lies between minus infinity to plus infinity, which is the PDF of Cauchy distribution. So, if y equal to tan inverse of x is a monotonic increasing function, so then Fy of y equal to fx of x of modulus of dx dy. So, you know what is x and y equal to tan inverse x, therefore, x equal to tan inverse y. So, x equal to tan inverse y. If with respect to y, then it become 1 by 1 plus x square, it become 1 plus y square. Now, we have a tan inverse x of with respect to x is 1 by 1 plus x square, because x equal to tan y. Now, we have what fx of x is 1 by pi, dx by dy equal to 1 by x square into corresponding secant square y. Therefore, the value is equal to 1 by pi. So, as x equal to tan y, then 1 plus tan square is secant square y, secant square y to get cancelled if x equal to tan y. Therefore, we have 1 by pi. Therefore, y is uniformly distributed in the interval minus pi by 2 to pi by 2. And next question, if x has an arbitrary distribution function f of x over x, and find g of x, so that a random variable y equal to g of x may be uniformly distributed in the interval 0 comma 1. So, if x is uniformly distributed in the interval 0 comma 1, find g of x, so that the random variable y equal to g of x may have an arbitrary distribution with the cumulative density function f of y over y. So, if x is uniformly distributed in the interval minus 1 to 1, then find g of x, so that the random variable y equal to g of x may have the density function f of y over y equal to 2 e power minus 2y. So, when y is positive, this is a given. So, the solution is, if y is to be uniform in 0 comma 1, then f of y over y equal to 1, and f of y over y equal to integral 0 to y f of y over y dy equal to what, because it is 1, therefore 1 into integral dy is y, upper limit minus lower limit we have y. So, f of g of x over y equal to g of x, and f of y over y is nothing but probability of y less than or equal to y. So, capital Y equal to g of x, substitute here, and from this x equal to g inverse of y, and g inverse of y is nothing but x, therefore, probability of x less than or equal to x. So, the corresponding notation is f of x over x. So, from this f of g of x over y is equal to f of x over x, and g of x equal to f of x over x from 1. So, that is the inference we got it from y equal to g of x and x equal to g inverse of y. Therefore, g of x is f of x over x. If x is uniform in 0, 1, therefore, f of x over x is x, and f of y over y is f of x over x. Therefore, f of g of x over y equal to x, and g of x equal to f inverse of x over y. So, if x is uniform in the interval -1 to 1, then f of x over x is half, and f of x, capital F of x is it simply differentiate or corresponding function, we can write 1 by 2 into x plus 1, and f of y over y is 2 into e power minus 2i, and capital F of y over y is nothing but integration of a small f of y. Therefore, integrate of this we have what, e power minus 2i integration is e power minus 2i by minus 2, and then upper limit is lower limit, upper limit minus lower limit we have 1 minus e power minus 2i. So, by 2 these two are equal, therefore, 1 minus e power minus 2i equal to 1 by 2 into x plus 1. So, we need y equal to gx already we taken, substitute it, and then from this e power minus e power minus 2 g of x equal to 1 by 2 into x plus 1, and e power minus 2 into g of x equal to minus 1 by 2 into x plus 1, and then taking log on both sides we have g of x equal to 1 by 2 into log of 2 by 1 minus x will come. So, this is the corresponding solution when x is a uniform. And another example, if two independent variable x and y having a density function f1 of x and f2 of y is given, find the density function of their sum u equal to x plus y. Now, according to the theorem, fu of u is a corresponding formula 0 to u, f of u minus y over x into f of y over y into dy, where u is positive. You already given in the hypothesis f1 and f2, f1 and f2 is given, substitute it, so that see base are equal, add powers, 2 into 3 is 6, and e or base power is e power of minus 2u plus 2y by minus 3y. So, we have what, e power minus 2u into e power y. So, e power minus 2u is a constant, take it outside. So, e power minus y into dy will come. Now, e power minus y integrate it. So, e power minus y by minus 1, and then upper limit minus lower limit you do that, therefore, it becomes 1 minus e power minus u, where u is positive. So, this way we can find out the summation of two density function. Next example, if x and y are independent random variable, if y is uniformly distributed in the interval 0, 1, show that density function z equal to x plus y is given by f of z over z equal to f of z over x minus f of z minus 1 over x. So, according to the theorem, we can directly write the definition of f of z over z is integral minus infinity to plus infinity of the given function of f of z minus y over x into f of y over y into dy, and given hypothesis f of y over y is 1 provided y is lies between 0 to 1 and f of z over z is 0 to 1 fx of z minus y into dy. Now put z minus y equal to t, therefore substitute here, it becomes t f of x t dt, because z minus y equal to t, therefore minus dy equal to dt, therefore change the limit when y equal to 0 t equal to z, when y equal to 1 t equal to z minus 1. So, that is why the limit change z minus 1 to z, therefore fx of t into dt. Now, if you integrate fx of t dt is f of x of t minus f of t over x, and upper limit minus lower limit we have f of z over x minus f of z minus 1 over x. Next example, two function f of x over x equal to c into e power minus cx into ux, and f of z over z equal to c square into z into e power minus cz uz. Find f of y over y if z equal to x plus y and x and y are independent. Here u of x is a unit step function, therefore u of x equal to 1 when x is positive, 0 if x is negative, therefore f of x over x is equal to c into e power minus x cx, where x is positive, and z over z is c square into z e power minus cz. Therefore, according to the theorem, simply product them, so that we have a integral c square z into e power minus cz is equal to integral 0 to z c into e power minus c zy into fi of y over dy. Now, recalling that and partially with respect to z on both sides, so that the LHS of the integral is equal to dou by dou z of integral a to b of z phi of zy dy equal to the RHS is integral a to b of z dou phi by dou z into dy plus phi of z comma bz into dou by dou z of bz. Now, you take equation 1, differentiate 1 partially with respect to z. So, what happened? C square keep as it is, and uv partially with respect to z being uv will come. Once with respect to z is c e power minus z, and c square keep as it is, z also keep as it is, e power minus c z differentiate is minus c into e power minus z, c into c is c cube, therefore minus c cube into z into e power minus c z will come, and RHS is integral 0 to z, that also partially with respect to z, c keep as it is, here differentiate partially with respect to z, therefore minus c into e power minus c of z minus y, already one c into c square, and minus c is there, therefore minus into plus is minus, and fi of y as it is. Since the function is associated with the LHS is no limit and RHS limit and associated with the arbitrary constant c of fi of z. Now, you integrate these ideas with the help of the integration by parts. Therefore, the resultant is integral u dv equal to uv minus integral v du technique. Now, apply it, it becomes minus c into c square z into e power minus c z, and this keep as it is. Now, substitute 1 in this equation, so that fi of z equal to c into e power minus cz, where z is positive, and fi of y over y is equal to c into e power minus cy, where y is positive. So, this way we can take a solution to the problem of 17. Next 18th problem, the current I and the resistance R in a circuit are independent continuous random variable with the following density function f of I over I equal to 2I, where I varies from 0 to 1, otherwise 0. F of R over R is R square by 9, where R is lies between 0 to 3. Find the PDF of the voltage E in the circuit. Here E equal to IR. Now according to the theorem, F of Z over Z is minus infinity to plus infinity by 1 by modulus of Y into F of Z by over X of Fi of Y dy. Here Z equal to Xy and X and Y are independent random variable. You take X equal to I and Y equal to R and Z equal to E. So we have F of E over E equal to integral minus infinity to plus infinity into 1 by 1 modulus of R into Fi of E by R into F of R over R. So 1 by R is nothing but absolute value is R only. So Fi of E by R, this is given here. So it becomes what 2 into, so first statement. So this statement we have to substitute here. Fr of R, substitute this statement here. So that simplify. So the integration becomes integral E to 3 1 by R square. So 1 by R square into 2 into E into R square by 9. So R square get cancelled. So we have to integrate. So this becomes what 2 into E into R, that is corresponding to function Fe of E will come. Similarly, we can go for Fi of E by R, replace E to E by R, so that 2 by E by R. Therefore, E by R is lies between 0 to 1. If R is greater than or equal to E, corresponding value determined. If E equal to R, then Fr of R equal to R square by 9, that directly given. So satisfies here, and R ranges from 0 to 3. Therefore, hence the limit of R taken as E and 3. Therefore, F of E over E equal to 2E by 9 into 3 minus E, where E lies between 0 to 3. Next example, X and Y are independent random variable of the following n of 0, 2. Prove that Z equal to X by Y follows a Gauss's distribution. So the solution is F of X over X is 1 by 2 into root 2 pi into E per minus X square by 8, and Fi of Y equal to 1 by 2 into root of 2 pi into E per minus Y square by 8, where minus infinity less than X and Y less than infinity. So according to the theorem, we have write directly F of Z over Z is minus infinity plus infinity of modulus of Y into F of YZ over X into F of Y over Y into dy. You know F of X over X is a value, and then F of Y over Y is also you know the value, substitute it. So that 1 by 4 pi integral 0 to infinity, because all are even, therefore it becomes what twice of 0 to infinity will come into Y into E power minus of 1 plus Z square into Y square by 8 into dy will come, and then we have to integrate since it is an even function. Therefore, if you integrate it, so we have 1 by pi into 1 by Z square, 1 plus Z square will come. So this is called as probability density function of Cauchy distribution. And next one is the problem related to Jacobian. If X and Y are independent random variable of the following n of 0, 2, find the PDF of Z equal to 2x plus 3y. Now we introduce the auxiliary random variable W equal to y, and Z equal to 2x plus 3y where and W equal to y. Therefore, from this x equal to 1 by 2 into Z minus 3w and y equal to w. So we got x as well as y. According to the Jacobian transform, J equal to dou of x comma y by dou of Z comma w. The meaning is dou x by dou Z and dou x by dou w, dou y by dou Z and dou y by dou w. Now you take x partially with respect to Z, we have from this here off, and partially with respect to x of w is minus 3, and similarly y partially with respect to Z is 0, and y partially with respect to w is what 1, and determinant expansion we have 1 by 2. Now, we have two independent random variable f of x comma y over x comma y is what corresponding 1 by 8 pi of e power minus of x square plus y square in by 8. So, x and y lies between minus infinity to plus infinity. Therefore, we have a joint probability density function is f of z comma w over zw is modulus of j of f of x comma y over xy. So, modulus of j is a Jacobian value is 1 by 2, and f of xy value is this one, you substitute here. Therefore, we have a probability density function and obtain the integrating of fz of w with respect to the range of w. Therefore, f of z over z equal to 1 by 6 pi integral minus infinity to plus infinity of this integration function. Now, e power minus z square by 8 by 13 is a constant, take it outside, rest of the integral minus infinity to plus infinity e power minus 13 into w minus 3z by 13 the whole square by 32 dw. So, integrate it, you can get the value of 1 by 2 into root 13 into root pi into e power minus z square by 2 into 2 root 13 whole square. So, based on this value we can write n of 0 comma 2 root 13. Next, if x and y are the exponential distribution with the parameter I or 1 and are independent, find the PDF u equal to x minus y. So, f of x over x is e power minus x and f of y over y is e power minus y. We know that x and y are independent. Therefore, simply f of x comma y is f of x over x into f of x over y, y over y. Therefore, e power minus x into e power minus y is e power minus of x plus y. And I hope you know the previous problem. And now this problem we have to take a random variable v equal to y along with u equal to x minus y. So, x you got it, y you got it, using the Jacobian we have 1. Once you got the Jacobian, we have a formula for joint probability distribution function f of u comma v over uv equal to modulus of j into f of x comma y over x comma y. Therefore, already we know f of x comma y over xy is e power minus of x plus y, x you know, y you know, substitute it, you have e power minus of u plus 2v. Now, the range of u and v is found and the map of the range of the transformation is x equal to u plus v and y equal to v. So, that we have a map x comma y related to x equal to u plus v and y equal to v corresponding the line can be extended. Since v is greater than minus u, the picture represent like that. When u is negative and v is positive when u is greater than 0. So, therefore, f of u over u is equal to integral minus u to infinity of e power minus of u plus 2v dv when u is negative, and integral 0 to infinity e power minus of u plus 2v into dv is when u is positive. So, f of u over u equal to 1 integrate with respect to v, we have e power u by 2 and integrate second one is e power minus u by 2 when u is positive and negative. Next, the joint probability distribution function f of x comma y, f of x comma y is x plus y, and find the probability density function of u equal to product of x y. So, here v equal to y and product of x y mean x equal to u by v and y equal to v, and apply the Jacobian transformation, we have 1 by v. So, we have a joint PDF of f of u comma v base uv is modulus of 1 by modulus of v into f of x comma y over xy. So, f of xy over x comma y is x is u by v, substitute here, and y is v, substitute here, and modulus of v is keep as it is. Now, the strip is given 0 less than or equal to x less than or equal to 1 and less than or equal to y less than or equal to 1. Therefore, corresponding picture is this, and if y equal to v, then v equal to u, then it passes through the origin of with respect to u and v. So, we have the limit of 0 less than or equal to u by v less than or equal to 1, corresponding if v is 0 to 1, or 0 less than or equal to u less than or equal to v, or 0 less than or equal to v less than or equal to 1. Therefore, PDF is f of u over u equal to 1 by integral u to 1 f of u comma v base uv dv, and we know the function, substitute here and then integrate it, 2 into 1 minus u will come.